Mark Johnson-Barbier, Salt River Project. So I may be a little bit different from everybody else because I want to start out with the word sophisticated. I don't like using it at all to describe the adversaries that we face. I don't think it gives the right terminology for what it is. So I know it's title. I was going to try to apologize to sit ahead of this, but when I think of the adversaries that we're looking at and the ones that we're worried about, the advanced persistent threat, sophisticated doesn't generally come to my mind because, well, as an example, if you red team your environment or you bring in a, let's say pen test or something like that, when you bring that group in, they're not going to go to the most sophisticated, coolest, best zero day that they can get to. They're going to start off with what's the lowest thing. And if they can't get through one way, they're going to find the next thing. And if they can't get through that one, they're going to move on to the next one. They're persistent. I think persistent is a better word to describe. If we want to get pedantic about it, it's a better word to describe the threat that we face across all of our networks, right? It's the same on board. I think we all know it. I learned it from my 11-year-old. When he gets hungry, he knows perfectly well how to go in and get food. He knows perfectly well how to sit down at the dinner table, but he doesn't want that. He wants in and out, right? So we hear it starting at about 4 o'clock before dinner. Can we go to In and Out tonight? And every 5 to 15 minutes, there's another word or something very persistent. I think if you start looking at your kids, you start understanding the level of persistence that's there until you finally just, okay, we're going to In and Out, right? It's just easier to go do it sometimes, and he doesn't always get in and out. But I've heard it said that adversaries are lazy. Yeah, but they work at it. They're trying to get in, and they do whatever it is that they need to do up to the level that they need to go to get over the berm and get into your networks, right? So it's really not, I don't like lazy either, but it's a good description, but it's really that they want to know how to solve a puzzle, right? When you start looking at the people who go into red teaming and trying to get into networks, a lot of times it's a puzzle for them. How do I get through this maze? How do I get through the escape room and get into that network that I'm there? If there's a way in, they're going to find it. So when you get down to it, the controls-based approach, I think, ends up failing at that level, that our networks have moved from a complicated environment. And I think Michelle hit on this earlier, a couple things that I think she got exactly right. As we move from complicated to complex interrelated environments that Mark talked about, there's data moving in and out of all of those. It starts breaking down when you start trying to list out the controls. You go from, was it 730 some odd or 80 some odd version and 853 to now apply those to all of my pumping stations, my SCADA systems, my whatever they are, and very soon you're into a level of complexity that we just can't hit with checkboxes, right? We're just not going to be able to do that. The other thing that I think about our adversaries is that they read the manual, right? They know how the systems work better than we do in most instances. We have situations where somebody has designed a system and they know how it works and they hand it over the wall to the other system. And in network security, in IT and OT, we're designing in silos. We have the endpoint silo, right? They're responsible for their Windows devices. We've got the Linux team that's responsible for the firewall people over there. Everybody's designing things in silos, but we don't have that integration to say, where's the big picture? Who's looking at how all of things work together? I think as we start looking at that, well, the adversaries that we face are looking at that. They're trying to get into what is the weakness that I can find immediately, and if I can't find one, I'm going to go dig for one that doesn't exist. They'll start getting into the analyzing the actual executables, trying to find their way in, and that sort of stuff. Trying to watch my time here too. So I think Sid's slides, while I don't like sophistication, on the slide where, I don't know if we can go back to it actually. Does this go back? Yeah, right? Oh, it's going to play it. Yeah, the beer guy. Understanding the weakness. So to use those words, that I think when we start understanding what it is that we need to do, we need to understand our systems, our networks, our everything, our processes better than the adversaries. We really have to go in and get better at understanding it. And it's not just in a silo. It's not just in a, I understand my endpoints, I understand my servers, but yet our teams are structured that way. They're built that way for a one sort of, I'm defending my piece of the puzzle, right? I've got my battle fought and won. They got in through the other guy's things, or her thing, or his thing. It's always somebody else's because mine's perfect. I've isolated my system. I've got my air gap. We were talking earlier, I've seen as many air gaps as I've seen unicorns, to paraphrase Eric Byers, right? They just don't exist on this planet. And I have to add on this planet because somebody pointed out that the Voyager spacecraft and the Mars rover are probably, the one that broke is probably a legitimate air gap because nobody's getting to that in any reasonable time frame. So as our networks increase in complexity, we're not going to solve this by dealing with risk the same way that we've done it before. The more complex our environment gets, the more risk isn't about reducing it, it's about transferring it, right? If we call Stuxnet the beer drinking game, right? Drink whenever you hear Stuxnet. But if you start looking at it in terms of how those adversaries were getting into the uranium enrichment plant, they didn't look at the network and say, oh, it's not internet connected, we can't get in. Sorry, we're going to have to go on to the next project. They looked at it, they hit a barrier, and they went to the next one. So one risk that was validated by a pretty good perimeter defense then moved on to a transfer to another defense, another system that needed to be in place to block it, until it had to be an insider, until it had to be, whatever ended up happening. The risk didn't get blocked or reduced, it just got transferred because Equation Group, or whichever one you want to call it by, they're a persistent threat. They're the ones that are going to get in regardless of the controls you have in place. They're going to be there, right? They're going to make their way in somehow, somewhere. They're not just going to go back to their managers and say, well, they have the perfect network so we can't get in. There's always going to be a next thing, and those are our adversaries. Those are the ones that we're defending against. So we've got to look at it that way. Now, when you start looking at the adversaries from the standpoint of we're no longer dealing with complicated adversaries where we can break it all down and have enough cybersecurity professionals. I mean, the old day, when you start thinking of the world wars and that sort of stuff, it was more about, I needed to know where the tanks were and where the planes are and where the soldiers are. And it was a small enough series of data that you could put enough people onto the system to solve that problem, right? It was rationalized down to a small enough amount. But as the interrelations between our networks have grown so much, we have a very difficult time predicting every possible interaction of any given system. One system depends on the fuel, which depends on this other system, which depends on the first system, right? We have many different ways that somebody's going to be able to go in and break into these systems or break our processes. If we're going to go in and solve that problem, we have to start getting away from the reductionist sort of thinking and start realizing that inefficiency is okay in our environment. It's okay to go in and spend some time doing things that are not efficient for the sake of being efficient. It's okay to work with our, as Michelle was pointing out before, it's okay to work with our competitors in this space. It's a good thing because we're going to raise the level of defenses together. And I think we have to get to that point where we're working together in building it. And I think Michelle's talk said it best. Team, when you start looking at what it is, when the level of adversary moves from complicated to complex, we have to do the same thing. We have to adapt our defenses in the same way that the adversaries are, which is they're moving from a individual, the proverbial hacker, sitting alone doing their thing, into a team-based approach. We've got to do the same thing. We've got to start building teams that are going to defending our networks. We're going to start working internally. I mean, we all know it. It's a problem, right? You go out to in our situation, at one plant, we have really good relations. At another one, not so well, right? Depends on the personnel, and I know that it exists that way pretty much across the board. So I think the way we solve this problem, when you start breaking it down into a root cause sort of analysis, I think we've got to start looking at building a team-based approach for going in this and sharing that information and working together. So sort of some of the SD-WAN and stuff that were discussed earlier, that as we see these threats and we start to identify them, we need to share that information out and let people react and respond to them faster so that together we're solving the problem as a nation or as an industry rather than just solo ourselves. So I think that does it.